Hello and welcome to this video on reducing fractions. In particular, we're going to look at simplifying a complex fraction, and then we're going to look at simplifying a fraction that's going to come up for those of you that are going to go into calculus. Alright, so this first one we have is a complex fraction, and the reason we call this a complex fraction is because we have fractions within our fractions. So in the numerator, we have 5 minus the fraction x plus 1 over x. And in the denominator, we have 3 plus the fraction x minus 1 over x plus 1. Now what we're going to do is we're going to treat these actually as 4 little mini fractions. Our 5 and our 3 we're going to treat as a fraction. It's a rational number. We can always write it as a fraction by dividing 1. And we're going to look at each of these 4 mini fractions. The way I'm going to approach this problem, this isn't the only way, but the way I'm going to do it is to find the LCD of all of those mini fractions. So in this case, we've got a 1, an x, a 1, and an x plus 1. So our LCD of those mini fractions is 1. 1 doesn't really do anything when we multiply by it. So 1 times x times, we've already got the 1, times x plus 1. So x times x plus 1. What we're going to do is we're going to multiply each of those mini fractions by that LCD. What we do to the top, we have to do to the bottom, and we're going to distribute it to each of those pieces. So we're going to multiply this by x times x plus 1, and then distribute that to each term. So when we do that, we've got a 1 in the denominator of the 5, and so that's not really doing anything. So we've got 5 times x plus 1, and then we've got the fraction x plus 1 over x times x plus 1. And if you want to skip this step and go ahead and simplify that fraction in this step, you can. In the denominator, when we multiply it by our 3, we're going to get 3 times x plus 1 plus our fraction x minus 1 over x plus 1 times that LCD x times x plus 1. Now the goal of this step is to get rid of all of those mini fractions, because notice we've got an x in the denominator and then an x in that LCD that are going to divide out. And the same thing's going to happen in the denominator. We've got an x plus 1 that's going to divide out on that last mini fraction. So we get 5x times x plus 1 minus, this is more than one term, we need to make sure and put it in parentheses, x plus 1 from this numerator, and then we have an x plus 1 left over from our LCD. If you want to write that as x plus 1 quantity squared, you're free to do so. In the denominator, we get 3x times x plus 1, and then plus x minus 1 in parentheses times that x that's left over from our LCD. Now let's go ahead and expand combine like terms in our numerator and our denominator. So we can distribute 5x. We'll get 5x times x plus 1 is 5x squared plus 5x. And then x plus 1 times x plus 1, or x plus 1 squared, is going to be x squared plus 2x plus 1. But we want to subtract that. Make sure that you put that in parentheses so we can remember to distribute that negative. In the denominator, we're going to distribute 3x. So 3x times x plus 1 is 3x squared plus 3x. And then we can distribute the x. This is a plus sign, so we don't have to have parentheses. We're not going to distribute anything here. So if we distribute that x times x minus 1, we'll get x squared minus x. Now let's distribute that negative. Make that a negative x squared, a negative 2x, and a negative 1. (5x squared) and a negative x squared is going to be 4x squared. And then we've got 5x minus 2x is 3x, and then minus 1. And then in the denominator, 3x squared plus x squared. That's going to give us a 4x squared. And 3x minus x is 2x. Let's go ahead and factor this. Factors, this one's got a leading coefficient that's not 1. So we're looking for factors of -4 that add to a positive 3. And the factors we want are 4 and -1. And so we can do this off to the side. 4x squared plus 3x. Use whatever method of factoring works great for you. I'm going to go ahead and use the AC grouping method. So I'm going to replace that 3x with a -x plus 4x. Getting those numbers, those coefficients from there. And then -1, don't forget about that on the end. And then if we factor out the GCF in the first group, we've got an x. That leaves us with 4x minus 1. In the second group, again, 4x minus 1 is already there. I'm going to go ahead and factor out a 1 just to keep it in that grouping format. Factor out the GCF now of 4x minus 1. And when we do that, we're left with x and plus 1. So our numerator factors as 4x minus 1 times x plus 1. In the denominator, we've got a GCF. We can factor out a 2x from 4x squared and 2x. And when we do that, we're going to be left with a 2x in our first term and a 1 in our second term. We don't have any common factors here, so that's really as simple as we can go. And since nothing factors, you could really leave it in either of those last two forms. All right, let's look at one more example in this video. This is something that shows up when you're doing calculus. And so those of you that will be moving on to Calc 1 or a business calculus, this is something that's going to show up in that scenario. This is the result of what we call the quotient rule. We're not worried about how we get this. Now we've got to do the simplifying. So what we have in the numerator here, we've got the quantity 7x plus 5 times 2x minus x squared times 7 all over 7x plus 5 squared. Now, we do have 3 terms here. We've got our 7x plus 5 times our 2x, and we have our x squared times 7 are our 2 terms in the numerator, and then in the denominator, there's only one term, that's 7x plus 5 squared. But unless we have any common factors to all 3 pieces, we cannot divide out. So we cannot cancel this 7x plus 5 because we don't have a 7x plus 5 at the end of the numerator. So on this one, we can look and see we do actually have a common factor that we could factor out in the numerator. We have an x multiplied in both of them. If you want to factor it out, you can. I'm going to go ahead and leave it in. I'm going to go ahead and distribute this 2x. So 7x plus 5 times 2x is going to be 14x squared plus 10x. And then x squared times 7, normally we see that written as 7x squared. So I'm going to write that as minus 7x squared. I'm going to leave the denominator alone. It's already factored. 7x plus 5 quantity squared doesn't have a GCF or anything that we can factor out of that. And then simplifying the numerator, 14x squared and minus 7x squared gives us 7x squared plus 10x over 7x plus 5 quantity squared. If we wanted to, we could factor out that x. Again, we could have factored that x out in the numerator at the first step. When we factor that out, we're going to be left with 7x plus 10. There's no GCF there. It's not the factor we have in the denominator, so you could really leave it. You could argue either one is simplified. All right, I'll see you guys later.